NASA is one of the most beloved organizations in the US and beyond. It is the dominant player when it comes to the exploration of solar system planets, human spaceflight, and of course, astronomy. In a 2023 Pew poll, 69% of Americans believe it is essential for the US to be a leader in space exploration, and this is broadly true for both Republicans and Democrats. But is NASA and all of the basic science it supports in trouble? Join me today as we explore this question with some hard numbers. Just in the last year, there have been several stories of NASA facing a funding crisis. For the 2024 budget, the White House requested $27.2 billion for NASA, but Congress cut that by $1.8 billion, giving NASA the first budget cut for over a decade. As a result, NASA was forced to lay off 530 employees, hitting NASA's Jet Propulsion Laboratory especially hard. The Mars sample return mission, previously planned for 2033, requested $949 million, but that was cut back to $300 million, and now the mission is pushed back to 2040, a delay compounded by technical challenges. Finally, NASA's Chandra Space Telescope, a crucial resource to X-ray astronomers, faces massive budget cuts that plunge the budget down below 8% of 2023 levels over the next 5 years, despite the fact the spacecraft is still functioning. This has been a bad year for NASA, but many worry that it could face even darker years ahead. As an astronomer, cuts to NASA are obviously of major concern because it is the principal way in which US astronomy is currently funded. Right now, federal grants still dominate the current funding landscape, and there are 3 principal bodies through which this happens. One is NASA, but there's also the National Science Foundation, or NSF, and then third we have the Department of Energy, or DOE. There's certainly overlap between these entities, but generally NASA focuses on space hardware, NSF on ground-based telescopes, and the DOE on astroparticle physics. In fiscal year 2023, NASA had an astrophysics budget of $1.51 billion. In contrast, NSF's Division of Astronomical Sciences received $305 million, and DOE is somewhere in the tens of millions of dollars when it comes to astronomy. NASA's astrophysics budget is obviously huge compared to the likes of you or me, but let's give that number some perspective just for fun. Compared to just one individual, Elon Musk, the entire NASA astrophysics annual budget is less than 1% of his net worth, about 2x below what he might expect in annual dividends alone. Now, I get it, this is government funding and we want to reduce the deficit, but in 2023, Congress allocated the Department of Defense an extra $1.5 billion, that's the same as the entire NASA astrophysics budget, to purchase extra F-35 aircraft that the DoD didn't even request. And if you're a US taxpayer, the NASA astrophysics budget represents less than 1/3000th of the tax money you paid last year, 0.03%. Isn't exploring the universe worth a fraction of a percent of our resources? In the context of NASA's total budget, astrophysics is a relatively small part of the pie, just 1/17th of last year's appropriation, with the rest supporting many other amazing programs like planetary science, human space exploration, the Orion spacecraft, low Earth orbit operations, Artemis, and the International Space Station. I don't think we say this enough, just how incredible NASA is. It is an internationally recognized symbol of technological wonder, scientific excellence, and it embodies the very spirit of human curiosity. JWST has been a sensational hit in this regard, with its widely publicized images becoming iconic vistas of what lies beyond our cosmic shore. And if you live in the US and believe, as I do, that NASA and its astronomy programs are more than worthwhile, then there are some things you can do to help. To save Chandra, astronomers have put together a website appropriately called savechandra.org that outlines what to do. Link down below in the description. The best way to help is to contact your senator or representatives and express to them that Chandra should be saved. I'll put some links down below of how to do that, even what to say. It can take literally less than a minute if you do it by email, so please do check down below in the description for all that information. And of course, all of this applies to NASA astrophysics more broadly. This really is the best way to let them know that this program matters to you. Hopefully, in the short term, we can reverse these cuts, but many worry that this could become a more common occurrence, and with it, we might let slip that human will to explore the final frontier. This is why I am making this video. I don't know about you, but I am not willing to let slip this dream that I have had since a boy. I am not willing to go quietly into that good night. Now, the cause for concern isn't just reactionary disappointment at this year's budget, it goes much deeper than that, and voices of concern have been making these arguments for over a decade already. Although there are many facets to this, we are going to focus here on just two key issues, two forces that threaten NASA's future in a very real way. Before we explore these, let me first thank our sponsor supporting the video production costs of this video, that's Incogni. I love Incogni because they address a growing problem in our modern world, how our private information is now being actively sold and traded between companies at your expense. I'm talking home addresses, employment history, phone numbers, and even social security numbers. Incogni is a subscription service that fights back, scanning databases for your information and then persistently requesting that your data be deleted until they comply with the law. Log in and you can see just how many databases are harvesting your information and the status of their compliance. My phone used to ring off the hook with scams to such a degree that I almost gave up answering the phone. In another case, a stranger called me up and read out my home address to me that they'd somehow dug up online. I got to a point where I was just sick of this crap. If you want to fight back against this too, then head to incogni.com/coolworlds to get an exclusive 60% off their annual plan. Once again, that's incogni.com/coolworlds. Clicking that link at the top of the description box helps support us too, and will put you back on track to taking your information back. Now, back to the video. So, two reasons why NASA faces fiscal challenges in the years ahead. Number one, flagship missions. To see this, let's look at the development of JWST, the James Webb Space Telescope. In the early 1990s, astronomers began discussing what kind of flagship space telescope might come after Hubble. The HST and Beyond Committee was formed to answer this question, and in 1996 they recommended an infrared space telescope at least 4 meters in diameter. Back then it was dubbed the Next Generation Space Telescope, and frankly I wish they kept that name as a fan of Star Trek The Next Generation. The committee estimated that JWST could be ready by 2005 and could be doable for about $500 million. Of course, you probably know that that didn't exactly pan out, and in fact those estimates seem comically optimistic, a trend which kept happening for more than a decade. By 1998, the budget had been revised up to $1 billion. By 2000, it was 1.8. In 2002, it was 2.5, and so on and so on. By the time of its launch, the mission cost $9.77 billion, and that doesn't even include the launch cost which the Europeans provided at no cost to NASA. So we have a severe case of budget creep, and I think one has to wonder, how did the telescope end up costing almost 20 times more than originally conceived? There's a bunch of reasons here, from the technical challenge of telescope origami, the huge amount of testing needed to ensure reliability given JWST's orbit would be too distant for astronaut servicing, scope changes, and yes, many errors in the project's development. For example, an independent review board in 2018 deemed that the contractor Northrop Grumman had made multiple human errors, such as using the wrong solvent to clean propulsion valves that consequently ruined them, requiring 9 months of additional work to refurbish them with the original manufacturer. Additional issues were improper wiring that applied excess voltage to transducers and improper tightening of fastener bolts during shock tests that led to a large impact. And it wasn't just cost creep, the launch date kept creeping back too. Remember that we were supposed to get JWST by 2005, but it arrived 16 years tardy. For a while, it seemed like JWST would just never happen and would always be a few years out of reach, like fusion power or flying cars. And we can dunk on JWST for going wildly over budget all day long, but it is not the first flagship space telescope to do this. In fact, its predecessor, the Hubble Space Telescope, did the same thing. Originally proposed in 1977 to launch by 1983 and at a cost of $400 million, it didn't launch until 1990 and at a cost of $1.5 billion. And whilst that might sound at least better than JWST's overrun, the mirror wasn't even in focus when it launched, and it required astronauts to repair it soon after at an additional cost of yet another $1.5 billion. These overruns have had a severe impact on astronomy funding. Consider that NASA's astrophysics budget was around about $1 billion circa 2010 when JWST was being developed, but of course its final cost ended up being 10 times that of the available annual budget. It's like buying a car costing 10 times your annual salary. You are going to have to make some serious cuts in your day-to-day budget over many, many years. Now that's simplifying things a little bit, but the effect was undeniably real. In 2012, the astrophysics budget was brutally slashed from $1.1 billion to $600 million, and it didn't fully recover until JWST was out of the door. As much as astronomers love JWST, this situation was bemoaned by many, such as Martin Elvis, who argued for many smaller missions in lieu of one giant mission that eats up all of the budget for over a decade. Other astronomers like Stel Finney pointed out that other missions like LISA, a space-based gravitational wave detector, were pushed back massively due to these overruns. So what do we learn from all of this? Well, I would say that at a minimum, it would be prudent to take current estimates of NASA's next flagship mission with a pinch of salt, both in terms of cost and launch date. Already, astronomers are discussing what that mission should be, and the 2020 Decadal Survey converged on a 6-meter class space telescope designed to image at least 25 potentially habitable exoplanets. It's currently dubbed the Habitable Worlds Observatory, HWO, although I think most of us expect a rebranding down the line. My money is on the Carl Sagan telescope. The Decadal Survey Committee set a preliminary launch date of 2040 and a cost estimate of $11 billion, almost the same as JWST. So purely based on previous flagships, we might expect these numbers to push outwards, perhaps more like a 2050 launch at a cost of tens of billions of dollars. Now, yes, I know what you're going to say, SpaceX's Starship is on the horizon, and I agree, that might give us some optimism for cheaper launch costs. See our earlier video all about that. However, JWST's launch cost was only 200 million euros, which, let's face it, is a tiny fraction of the overall cost of the mission, and so even pushing that down to zero, it really wouldn't save us that much. A better hope is that the larger volume and mass afforded by Starship would dissolve some of the technical challenges that haunted JWST's development, so this gives me some optimism. But on the other hand, I can easily see the scope of HWO changing over time. Remember that JWST was originally slated to be a 4-meter diameter telescope, but ended up being 6.5 meters, because bigger is better. Personally, this really is my primary concern. The HWO team currently assume about a quarter of all Sun-like stars have Earth-like planets, but in fact, it could be much less than that, as we've discussed on this channel before. If so, the telescope will have to become bigger, because that would mean that the nearest Earth-like planet would be further away and thus around a fainter star. At a minimum, we expect the cost of space telescopes to scale as the diameter squared, as shown by my colleague Gerard van Bel. Now, if the mirror size ends up exceeding 8 meters, which by the way was what was originally proposed in earlier concepts, then a folding design will be needed even with Starship. So to me, while Starship could deliver real savings, it's not obvious that it's actually going to save us from a third flagship mission experiencing massive overruns once again. There's nothing more I'd love to see than the pale blue dot of an Earth-like exoplanet. It would be a monumental achievement and something I sincerely hope to see in my lifetime. But at the same time, in the decades to come, we also want to have different kinds of telescopes besides from HWO to answer different kinds of science questions. Help might come from considering radical telescope designs like Daniluk's inflatable Nautilus concept or, shameless plug, my own Terrascope concept that I've discussed on this channel before. Or perhaps we can answer our questions about life in the universe without these facilities at all, instead turning to the next generation of ground-based telescopes. It might be possible to think our way out of this problem to essentially have our cake and eat it without significantly increasing NASA's budget. Or we might simply need to spend more money on NASA. After all, these numbers represent a tiny slither of the US tax revenue each year. NASA currently costs about 0.5% of the federal budget, whereas a 2018 poll found that Americans typically thought it was more than 12 times higher than that. How is that for efficient government spending?
Consider, however, that the half a penny budget that NASA receives, if you double it, twice that, as unthinkable that is to so many, I assert that we can transform the country from a sullen, dispirited nation, weary of economic struggle, to one where it has reclaimed its 20th century birthright to dream of tomorrow.
As much as I'd love to see that happen, there is a real risk that it could go in the opposite direction, a squeeze that could potentially kill our hopes of one day detecting life on another planet. Enter concern number 2, climate change. In a recent Scientific American opinion piece by astronomer Seven Rasmussen, the terrifying prospect that JWST could be our last great observatory is suggested as a result of climate change. The link isn't perhaps immediately obvious, but rather is an indirect one. As the effects of climate change worsen over the coming decades, the economic impact will become increasingly severe, both in terms of GDP and federal spending priorities. Now, the future impacts of climate change are difficult to predict, both because climate modeling is extremely challenging, but also because human behavior is too. There's a range of possible scenarios ahead, but already the global average temperature is about 1 degree Celsius above pre-industrial levels. It turns out that climate change is expensive. On average, the US currently experiences an extreme weather event causing $1 billion of damage every 3 weeks, according to the US National Climate Assessment Report. For context, 40 years ago, it was just once every 4 months. According to the National Center for Environment Information, over the 1980s, the average cost of such disasters was about $21.7 billion per year, inflation adjusted. But over the last 5 years, that number has swelled to $122.5 billion. In a New York Times investigation published just last week, they report that in 18 US states, home insurers last year were unprofitable due to increasing damage to homes caused by severe storms, hurricanes, and wildfires. And of course, this is just where we are right now, with projections for the future looking much more dire. The Office of Management and Budgets estimates that climate change could cost the US up to $2 trillion every year by 2100. So yes, this affects NASA, but really it affects every branch of government and aspect of our lives. Clearly, extreme weather events are already costing the US economy, and when your home, your health, even your very life is on the line, then it's hardly surprising that NASA's next flagship space telescope mission is going to get deprioritized. Whether a future administration would indeed kill basic science in response to all of this is speculative, but we have to admit that it's definitely not going to help, and that NASA, astronomy, and indeed all basic science might face cuts in the decades ahead. Something we've been dancing around here is the value of doing astronomy. What is the fiscal return of taking a photograph of a distant Earth-like exoplanet? Indeed, what is the value of the universe? To explore space with our telescopes, satellites, and deep space probes, and even sometimes just our minds, requires resources, technologies, and an army of skilled individuals. You know, it's easy to dismiss such spending as frivolous, reminiscent of those who scorned our ancestors who dared to leave Africa or cross the tumultuous oceans to reveal new continents. The return of discovery is incalculable. It always has been. But even if there was no return, I for one still hold that there's something beautiful, nay, vital about doing something for the sheer intellectual curiosity of it? What meaning does our existence really have if everything we do only concerns our direct survival and comfort? Like animals, we just concern ourselves with ourselves. There's no abstract thought, no wonder, no art, no discovery. Our existence would be limited to our existence. I can't accept that. I won't. There has to be more to our lives. There has to be things that we do just for the pure pleasure of finding things out, of learning about who we are in this grand cosmic tapestry. I, for one, hope that we never stop exploring, stop learning and discovering, because without that, we're not really human anymore. So, until next time, stay thoughtful and please stay curious. Thanks so much for watching. If you enjoyed this, then please do consider hitting the like and subscribe buttons. Those two little actions really do help us out. And if you haven't already, you might want to check out the Cool Worlds podcast for many more great conversations. Look, if you're trying to find a way to support everything we're doing here, from the research to the podcast to the YouTube channel, then the best way to do so is to use the link up above and down below, where you can become a supporter to my research team, the Cool Worlds Lab, from as little as the price of a coffee per month, with access to all kinds of special perks. So please do check it out. Thanks again for watching.